Hello, students. All right, ladies and gentlemen, we are here in the actual laboratory today, and we're dividing this lab into two parts so that I can safely transition between the two parts in the camera and not blow myself up. So our lab activity is actually the classroom activity in your book on page 153. In fact, turn there, if you will, and let's look at the problem of today's activity. It reads, what happens when an acid reacts with a base? What happens when an acid reacts with a base? Think about it. We discussed it a little bit in our notes earlier this week, but what I'd like you to do right now is pause this video to give you time to write your hypothesis. What do you think the answer to that question is? Welcome back, and here we are. You have written your hypothesis, and I am going to be summarizing the procedures here for this particular lab. We have two different solutions before me, solution A and solution B. And the first thing we're going to do is identify which one is which. So we're going to be performing three tests on these two different solutions: the litmus paper test, the pH paper test, and the phenolphthalein test. And in addition to those three tests, I'll also be giving you my sensory observations using my schnoz. I'm going to share with you whether I detect an odor or not with these two solutions, and I'll tell you what I detect in terms of that odor. Okay, so the first thing we're going to do is identify what these two solutions are, and then we're going to neutralize them. We're going to enable them to undergo a special type of double replacement reaction known as neutralization. We'll see what the results of that are, and then we'll transition to the second part of the lab, and I'll have to make a second video for that because the second part will involve the use of the Bunsen burner. So we'll get to that in just a moment. So to begin, let's identify what these two solutions are. So we'll begin with the red litmus paper. Hopefully you remember from yesterday's lab what observations you should be making with the litmus paper test. We're going to take a strip of red litmus paper here first, and in your observations, you will see the two columns for the litmus paper test. The first one you can make for the red litmus paper, and the second you can make for the blue litmus paper. So let's do the red litmus paper first, and I'm just going to divide it in half. And I'm going to take the first half and divide it into solution A. So solution A, red litmus paper turns blue. Can you see that? The red litmus paper turns blue. I'm a little bit too far away, so I'll just hold it up for you. Red litmus paper turns blue in solution A. Solution B, red litmus paper in solution B. Red litmus paper stays red in solution B. Now let's go to the blue litmus paper. And I'll take one strip of blue litmus paper out of our container here. And no need to waste the whole sheet. I'll rip it in half. And by now, you probably have a pretty good idea which solution is which. All right, blue litmus paper in solution A. The blue litmus paper stays blue. Boop. Now the blue litmus paper in solution B. Oh, wow, look at that. Blue litmus paper turns red in solution B. So for the litmus paper test, the end color for solution A is blue. And for the litmus paper test for solution B, the end color is red. That should tell you which one is which. But how strong are they? And I'm not telling you which one is the acid or the base. That's for you to observe. Let's use pH paper. So I'm going to take a single sheet of litmus paper out here. Here we go. And I'll divide it in half. And let's start with solution A. So solution A, and I'm going to hold my little canister with the colors on it to match the colors. Solution A, quick dramatic color change here. Wow, it looks like 14. Oh my. So the pH of solution A is 14. Yikes. That's pretty high. Now, solution B. Solution B, woo-wee. Solution B looks like a pH of 2. A pH of 2. And again, I'm matching up the colors on the pH paper color guide. All right, so now you have an even better idea of which one is the acid and which one is the base. And now for the next test, the phenolphthalein test. Phenolphthalein. I love this test. So here we go. I'm going to put 1 drop of phenolphthalein into both beakers. Beaker B and beaker A. And let's see what happens here with the phenolphthalein. Beaker B stays clear. Beaker A. Wow. Beaker A, can you see that? Especially against my lab jacket. Beaker A is definitely really, really pink. Now, I said to you earlier, I was going to give you another observation as well. So I'm going to waft. I'm going to waft, not snort. Waft. Yeah, I don't have to waft too much here, okay? Beaker B, you could add this with a separate column if you want. Beaker B has a very sour odor to it. Beaker B has a very sour odor to it. I'm not going to drink it, don't worry. But the odor is very sour. Beaker A, oh boy. Woo, I don't even have to waft. Oh my. Beaker A is extremely bitter. I'm not a fan of bitter. I prefer sour, but I'm not even really a fan of sour. I'm a sweet and salty kind of a guy. But Beaker B is sour. Beaker A, definitely a bitter odor. All right, so there are your observations for the tests. So you should have a pretty good idea as to which one is the acid and which one is the base. Now we're going to transition to the next part here of our lab activity. I'm going to move our testing equipment off to the side, and we're going to set up a titration experiment. What do I mean by that? Well, try to remember which one is which here. I'm going to take the contents of beaker A, and I am going to obtain 25 milliliters of solution A. You might want to write that down. 25 milliliters of solution A. I'm going to try and get it as precisely as I can here. So I'm going to be referring to the bottom of the meniscus. Wowie kazowie, look at that. My goodness so gracious. Right down to the last drop. Did I measure that accurately or what? Woo! All right. According to my little graduated cylinder here, I have measured 25 milliliters of solution A, and I'm going to put it into, pour with the spout, into this smaller beaker. I'm going to put that off to the side. Put this off to the side. And now here's what I'm going to do. I'm going to place this smaller beaker so that you can see it. In fact, I'm going to take a little piece of white paper towel here, and I'm going to put a little piece of white paper towel underneath it, so I think you'll be able to see it better. Ah, yeah, there we go. Okay, so you can see that a little bit better. So I have exactly 25 milliliters of solution A in this smaller beaker. Now, I have this other device here. This thing is called a buret. And a buret is like a graduated cylinder with a hole on the bottom. But that hole can be plugged up with this little spout. Okay? It's actually called a stopcock. And so by turning the stopcock, I can either open or close the hole, which is on the bottom of the buret. And what I'm going to do is to place solution B into the buret. So I'm going to take solution B and I'm going to pour it into the buret very carefully here, into the top of the buret. And you'll see it filling, hopefully. I'm not leaking, right? Good, I'm not leaking. So you can see the buret is getting more full. And this buret, I can see exactly what volume is in the buret. And I can measure down how many milliliters I'm going to be adding into the other solution. Now, I need to add just a little bit more to make my numbers easier. So hold on one moment. I'm just getting a little bit more of solution B because my brain is a little bit tired. And I want to bring that value up to a number that makes sense to me. It'll be easier for me to read if I'm on an even number here. So I'm just adding a little bit more of solution B into the buret. And the buret is actually labeled with lines and numbers in reverse order. So 0 is at the top. And that's what I have just brought it up to. I know it's out of the screen right now, but I have filled up the buret. 0 is at the top. So as I empty some of the solution B into solution A, I'm going to be able to tell exactly what the volume was that I added. And there's good reason for that. For those of you who are mathematically inclined, I gave you that titration equation the other day. N sub A times V sub A equals N sub B times V sub B. In other words, the concentration times the volume of the acid is equal to the concentration times the volume of the base. So for those of you that like a challenge, I'm going to give you some numbers here after I collect them. So I'm going to collect the numbers first. We already know we have 25 milliliters of solution A in the beaker. And what I'm going to do is slowly now add, I'm going to slowly add solution B into the beaker, and I want you to watch the pink color. Remember what the pink color is indicative of. What does that pink color indicate? So as I add the other solution, drop by drop, I'm also going to be swirling it around a little bit to see if anything happens to our color. Now you remember what the pH value was of the pink solution initially, right? Well, we're going to do something here. Keep on watching that pink color. Keep on watching the pink color. As I continue to add more of solution B, do you see it's starting to get lighter? I'm going to slow down a little bit here. It's getting a little bit lighter. I'm going to add it more drop by drop so that I can get it as perfect as possible here. Because what we are doing, and you may have guessed it by now, we're going to get rid of this pink color. And the way in which we're going to get rid of this pink color is through this reaction called neutralization. If the pink color disappears, I want you to answer this yourself. If the pink color disappears, does the reason for it being pink also disappear? Think about that. I'm slowing it down a little bit. A couple more drops here. We'll see. Go nice and slow till there's no more pink color at all. And that's it right there. Right there. Right there. There is no more pink color. The pink has gone away. If only I could do that with my gray. Make my gray go away. But anyway, all right, so there's the pink. Now, how much have I added? I have added 20 milliliters. 20 milliliters of solution B. So we started off with 25 milliliters of solution A, and 20 milliliters of solution B was required to get rid of the pink. And what I'm going to do right now is use a piece of pH paper to determine the pH of this solution in the small beaker. So give me a moment to get a piece of litmus paper out here. There we go. Let me have my forceps here. And I'm going to hold on to the color guide. I'm putting it in. Wow. Well, look at that. We now have a pH of 7. This solution here has a pH of 7. What does that tell you? What does that tell you? pH of 7. Let me also try and... I don't detect any odors anymore either. No odors whatsoever. So think about that for your observation. I'm going to tell you what we have here, and then I'm going to go to the last part of the lab with the Bunsen burner. So here's the deal. One of these two solutions was hydrochloric acid, HCl. The other solution was sodium hydroxide, NaOH. Hydrochloric acid and sodium hydroxide. I added the two together. I measured the volume of both. We neutralize the acid and the water. And don't say it out loud, but think about what is now in this beaker. And that's what we're going to find out in the last part of our lab. But before we go, I want to tell you one more thing. The concentration of the acid, of the acid was 1. 1 normal. It was a 1 normal solution. And for those of you that like a math challenge, while I'm getting ready for the Bunsen burner, why don't you calculate what was the concentration in normalcy? What was the concentration of the base? Because you know, it's all about that base, No trouble. All right, so at this time, I'm going to stop this first video, set up for the Bunsen burner, and we're going to see the end result of this little experiment in just a few moments. So for now, I'm going to say bye-bye.